Hello guys, as you can see, I've just made a digital clock using timer, counters and 7-segment display. So these are digital clock that you don't need to program in order to make. You just need to understand how timer, counters and 7-segment display work. So this is the source of power, and you can see here we do have the second display. Next we have the minutes display, and lastly here we have the hour display. What you need is just to understand the basic principles of counters, AND gates, and 7-segment decoders, that is BCD to 7-segment decoders. So that's what I've actually done in this circuit. As you can see, we have the hour 7 segments, so they'll display the time in hours. In the middle we do have 7 segments for the minutes, and lastly we have the 7 segments for the seconds. So the seconds will run when it reaches 60, then the minutes updates. The minutes also run when they reach 60, then the hours will update. The hours will run until they reach 23 hours. When it reaches 23, and when the 23rd hour is done, it will reset to 0. So the basic part of the circuit starts with the timer. So this timer, it's the one that works within at a frequency of 1 second. Then we have now the counters. We have counters. As you can see, these counters, there are 6 of them. So each counter is dedicated to each 7-segment. Then from the counter we have now BCD to 7-segment decoder. So there are also 6 of them, because each one is dedicated to the 7 segments, each 7 segment. So you can see 6 7 segments, 6 BCD to 7-segment decoders, and 6 decade counters. Decade counter that we are using is 74LS90, and BCD to 7-segment is 74LS47. So the 74LS47 is basically a common anode BCD to 7-segment decoder. So in order for you to use it, you must make sure that your 7-segment is a common anode one. Then here we have AND gates. So AND gates that we are using are 74LS08. So these are quad to input AND gate IC 74LS08. Yeah, then next we have reset buttons. Yeah, you are aware that you need to set time. So here we have two buttons, one for setting the minute. So this one here is for setting the minutes. Then the other button is for setting the hour. Yeah, so let's set the minute, let's say to 59th minute, and wait for the seconds to update and see what will happen to the hours. So let's click this and use it to set. Yeah, so let's set it to 59th minute. Yeah, I'm clicking the button there to do the setting of the minute. So 57, 58. Sorry, in this simulation I don't know why 8 is not displayed. Yeah, so we are in 59 minute. So 8 is not displayed in simulation, although all the connections are okay. I think it's an internal problem that comes with the software. So don't worry, because I've made the hardware version of this program and there is no any issue with it. Everything is clean and good. Yeah, so we are in 36th second. Let's wait for it to reach the 60th second and see what will happen to the minutes as well as the hour. Since we're in 59th minute, we expect it to reset to 0. Then the hour will now be 1 hour. So let's wait. 59, 60. So you can see the minutes have reset to 0, and now the hour is 1 hour, and the seconds continue to count. So seconds will count. When the seconds reaches 60th second, we'll have 1 minute. Again it will continue and continue until we reach the 59th minute. 60th minute, we'll have our resetting to 2 hours. Yeah, so in these are 24 hour clock system. So it's a digital clock that will display the time in 24 hours. Yeah. So which means it runs from 0 to 23rd hour. Yeah. Then the day will have passed. Yeah, so 59th, 60th. Yeah, you can see we have minute 1. Yeah, so I talked of the button for setting the minute. Let's click this other button and see. Yeah, so you can see this other button you can use it to set the this other button. You can use it to set the hour. So we are in 21, 22nd, 23rd. So we are in 23rd hour. So let's also make the minute to 59 and wait for the seconds to update and see what will happen. Yeah, so 59th minute, and now the seconds are updating. Yeah, so let's wait and see. As we wait, you can see the AND gates that I used from the IC. There are just 3 of them. So these AND gates, they are the ones that are responsible for updates that are needed for the hours and the minutes. Yeah, so they do the AND logic to see if the AND inputs are all true, then it resets. Yeah, so 57, 58, 59, 60. Yeah, you can now see. Yeah. Yeah, so that's the schematic. Here is the PCB layout. So this is the PCB that I made. You can see so many wires. It's because I wanted it to be single-sided so that etching can be easy. Yeah, this is now the 3D visualizer. You can see the counters down here, BCD to decoders up there, 7 segments. This is the AND gate. This is the AND gate. Here we have the timer. This is a capacitor. Resistors, we have several. 7805 there. This is a terminal block. We also have 2 capacitors. Yeah, so basically that's it. That's it about the schematic and the PCB design. Now let's go to the hardware and see how the hardware looks like and how it operates. And before that, let me show you. It's important for you to go through the data sheet of these ICs, like 74 LS90. You can see it's a decade counter, and the structure looks like this. So these are the pin, the logic diagram, and these are now the pins. It's good for you to understand them. Then the most important part that you should not neglect is understanding the truth table for BCD decade counter, that is LS90. Yeah. Again, another IC is the BCD to 7 segment decoder, which I said is a common anode 74LS47. So this is the structure, and the truth table is important to understand so that you may easily do the counting. Then here is the data sheet for the LS08. So you can see it has 4 AND gates, so it's a quad, 2 input AND gate, so 2 input and we get 1 output. Yeah, so AND means if input 1 and input 2 are both true, then activate or reset through the output. Yeah, so it's important for you to understand them. Now next, I'll take you through the components that I'll use. So this is the copper clad. This is a battery, 9 volts battery. So that's the power source. Here we have the battery clip. Here we have a terminal block. Next, we do have the potentiometer. The capacitors. Here we have various ICs. So LS74, LS47, 6 of them. 74 LS90, 6 of them, and 74 LS08, 1. Then here we have a timer, that is NE 555N. Yeah, so NE 555N. We have voltage regulator 7805. Next we have IC sockets, very important. So we have 14 pins IC sockets for the counters and the AND gate, that is 74 LS90 and 74 LS08, and also 16 pin IC sockets for the decoder BCD to 7 segment decoder, that is 74 LS47. Buttons are very important because they are the ones that we'll use to do the setting. They are the ones that we'll press to set our clock. Yeah. Then we have 220 ohms resistors. The resistors are important in that they'll be used to limit the current that flows through the 7 segment. Then here we have 6 7 segment displays. So in this case, since I'm using 74 LS 47, I need a common anode decoder. So this is a common anode decoder. You can see the part number 5611BH. That's a common anode decoder 7 segment. Yeah, display. Yeah, and basically having seen the components, then now we can dive into work. So I won't show you how the process of etching and drilling, but I'll just show the final result and how it works. Thank you. So these are 24-hour clock system. So it will display time in 24 hours format. Currently we are in 45th second. So when the second reaches 60th, then it's supposed to update the minute. So let's see. Yeah, you can see the minute has updated to the third. Then also we have a button here. So this button, when I click it, I can use it to set minute. So I'm clicking the button and using it to set minute. So if I leave it at 36th minute, it will continue from there. So let's put it to 59th minute and wait for the seconds to update and see what will happen to hours. Currently the hour is in 00, which in this case, if it's a 24, in this case, since it's a 24-hour clock system, that's supposed to be midnight. In real situation, it's supposed to be midnight. So let's wait and see. We're in 37th second, 40th. So let's wait and see. And you can see the source of power here. We do have a 9 volts battery. So 57, 58, 59, 60. You can see the minutes have reset to 0, and now 1 hour is gone. So we have 1 hour. And this button here, you can use it to set hour. The same way we saw that this button here, I'm using it to set the minute. So let's set the hour. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23. Now if I press it, it's supposed to go to 0, 0. Again, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14. I double pressed. So there we have 23. So 23, and let's put the minutes to put the minutes to 59. So 0, it resets. So the 60th, it resets. Yeah, so that's about the operation. So these ICs here, they are the counters. The counter. So from counter, so it's the hierarchy is like this. From timer is NE 555 timer, and this trim potentiometer here, we can use it to adjust the frequency in which the seconds are supposed to run. So you can adjust this to get the right seconds duration. Then from the timer we go to counter. Then from the counter we now have the BCD to 7 segment. Then from the 7 segment we do have the display, the 7 segment display. So decoder to 7 segment display. So you can see we have 6 counters and 6 BCD to 7 segment decoders, as well as 6 7 segment displays. This is the AND gate. So AND gate that we are using is 74LS08. The counter is 74LS90, and the BCD to 7 segment is 74LS47, which is used with a common anode 7 segment display. Then these tactile switches I've already shown. They are used to adjust to do the setting of the time. Then down here, this one here is a voltage regulator 7805.